Alright, let's turn next to Bayes' theorem, which is a very important theorem in statistics with many applications and many applications that are actually fun to think about. But let's just focus on its derivation for now and then work through a couple of applications later. So what you can see here is also a picture of Thomas Bayes. So he lived from 1701 to 1761. And Bayes' theorem is concerned with conditional probabilities. And the simplest form of Bayes' theorem can be derived from the multiplication rule for dependent events. And you know, if you have, for example, the probability of A and B, that can be written as the probability of A times the probability of B given A. And this can be rearranged to the probability of B given A, which is the probability of A and B over the probability of A. But let's quickly just stop here and let's visualize that here. So we want to know what's the probability of B given A. And we can illustrate that using a Venn diagram. And so we have two events, A and B. Let's see if I can. So let's say that's A and B. Maybe let's give it different colors, maybe. Maybe one orange and the other one blue. Okay, so we have here A, and the blue one is B. So then the intersection is A and B. Okay, so now the probability of B given A, we can see this is this intersection, probability of A and B. Over the orange bubble A. Okay, so but now let's just assume that somebody might be interested in the probability of A given B. Well, in this case, if the probability of A given B, so now everything is with respect to the probability of B. So that means in the denominator we have the probability of B. But the probability of A given B, the numerator is also the probability of A and B. Okay. So now what Bayes' theorem essentially does is it rearranges this term, probability of A and B, and isolates the probability of A and B, and then we substitute it into the probability of B and A. Okay, so now we can rewrite the probability of A and B as the probability of B times the probability of A given B. And this we just insert into the probability of B given A. And then we get Bayes' theorem, which says this is the probability of B times the probability of A given B over the probability of A. Okay, and here this is what we have, the probability of B times the probability of A given B over the probability of A. So with the help of a Venn diagram, it can be relatively easily derived. So again, we start out by acknowledging that the probability of B given A is the probability of A and B over the probability of A. But then we said, well, what if somebody wants to know the probability of A given B? Well, same intersection over the probability of B. But then we rearranged the probability of A given B and isolated the probability of A and B, in which case we got the probability of A given B, or the probability of B times the probability of A given B. Doesn't matter how you write it. I wrote it like this. Probability of B times the probability of A given B, it's the same, over the probability of A. I actually prefer to write it like this, because it looks so familiar to the probability of dependent events. Okay, but anyhow, so this is Bayes' theorem, and its usefulness lies in the fact that the same probability can be derived in different ways. And yeah, let's just stop here and then let's dive into a couple of examples.